So we're asking about using regression results to come up with equations. And I jumped into chapter 10, practice problems. And you can see just doing the scatter plot that you get. Looking at my picture here, which I gotta maximize it, I guess. All my little dots kind of lie right on the cubic line. So if I just had the dots here and then I plotted it, they would all lie perfectly. And I can see my R squares here. Depending on, I did lots of different attempts at regressions for it. And all of the R squares are exactly equal to 1. I mean, these ones aren't exactly, but fairly close. And you can see what ends up happening. This is a production function, so output should be 0 when the amount of labor is 0. So when I force the intercept to be 0, which is what I do in these two right-hand sets of equations, then again I get some results here with these coefficients 600 and -2. Pretty much all these runs that I have, the coefficients are 600 for L squared and -2 for L cubed. When it's not like that, like if I compared, when I compared these two regressions on the left, what I ended up seeing is my intercept, it's not showing it to be exactly 0 like it is over here. Here I checked that little box that said, make sure these coefficients are 0. Over here though, it's not showing them to be exactly 0, but they're pretty small. I mean, if you look at the actual numbers that are here, this is, negative, you've got 8 zeros, you've got a decimal place and then a decimal place here, 8 zeros and then 2 8s. So that's really tiny. And this one here too, it's a negative, but it's still pretty close to 0. This one, you've got a negative out front and then 0.9 zeros, and then it gets to 9.3. So even these where it's estimating some kind of intercept, some non-zero intercept, it's close enough to 0 for government work. I also did some runs because the book likes to do cubic equations without having an L term in it. And so when I ran this regression, I didn't actually include an L variable in here. I just left it off. But just to make the tables comparable, I kind of added an extra row in here and then put the L in there just to kind of show you that I didn't include the L term as an independent variable. So I get these results. If I'm wanting to come up with these equations for them, how to get total product, average product, marginal product, then again, the way that I set up the regression was to have Q, or total product, be the dependent variable. And either all three of these being the independent variables or just these two being the independent variables. Get these results here. And so again, the total product or the quantity was my dependent variable, and that equals, and I'll just, it doesn't really matter which one I pick, because if I didn't include an L term, then I don't have any L variable to worry about. If I didn't include an intercept, I don't have to worry about the intercept term. And when I did include an intercept, they were so close to 0 anyway, and I'll leave them off. This one is even insignificant too. When I did include an L term, when I did try to run a regression with an L term in it, I get sort of similar things where this one over here, the coefficient on the L is very, very small. It's very close to 0, and it's insignificant. This one is significant, but it's still very close to 0. I mean, you got a 0.9 zeros, then it goes 1.7. I mean, this coefficient here is 600. This one's -2. This one is 9 zeros and then a 1.7. So this is tiny also. And basically all the regressions that I'm running, if I get some value in the intercept term or the L term, all of them basically are close to 0 anyway. So just to make things simple, I said, well, it seems like I can boil all of these results down to saying that production seems to behave according to, -2 times L to the third plus 600 times L squared. So I get that little equation here. And from there, to get the average product and the marginal product, it's just doing algebra for this one. So average product is the total product divided by L. So I take this equation here and divide each of the terms by L. So I had -2 L cubed. Well, divide that by L gives me -2 L squared. Plus 600 L squared, divide that by L gives me plus 600 L. When I want to get the marginal product, I just take the derivative of the total product equation with respect to L. So the 3 gets multiplied out front, so I get a -6 L squared. The 2 multiplies in front of the 600, so plus 1200 times L.